These are self-milled USB-A PCBs, and I would like to show you how I made them and how you can make USB edge connectors yourself. And with that, welcome to my channel, Duct Tape Engineer. About a week ago, I thought about some projects to which I wanted to add a USB connector to. But how do you add a USB connector to one of your projects? Well, that is quite simple. You just buy some male or female connectors and solder them to the rest of your project, or if you have a PCB, change your PCB accordingly and solder a connector on there. But another thing you can do is add a USB edge connector like this to your PCB. This has both advantages and disadvantages. It is easier and faster and allows your finished project to be smaller, but it can be harder to manufacture and have a less professional look. But I'll get to that. I just wanted to see if this was possible, so I opened my CAD program of choice, KiCad, and searched for a USB edge connector. In KiCad, sadly there is no such footprint pre-installed, but in that case you can download one from the internet. I'll add a link for the footprint I used below. To test if this works, I made two different PCBs, a simple breakout board and a voltage converter. The voltage converter is not a realistic use case, at least not in the way I did it, as normally a USB male connector would receive power, not output it as it does in my case. But this is just a test anyway. So after modeling these two up, I exported the Dropper files and created my G-code files for my CNC mill. If you want to make your own and want to order them online, this is all not needed. I create my G-code files with FlatCam and OpenBuildsCam, which I have found to work okay together. About 1.5 hours later, my PCBs had finished milling and I soldered the other components to the tool boards. I chose not to add a solder mask to these PCBs, as it is not worth the hassle for me. The biggest problem with these PCB edge connectors, both when milled and when ordered online, is that PCBs are normally only 1.6 mm thick, and these USB connectors should be between 2 and 2.5 mm thick to friction fit into the female USB ports. For me, it was easy to 3D print some thin pieces and glue them on there, as you can see here. If you order your PCBs online, you can easily select other thicknesses, but that may be more expensive than ordering standard 1.6 mm PCBs. And then, for the first time in my life, something works on the first try, because these boards work without any problem. These do look quite scuffed up after a few uses, and they get dirty quickly, which makes them look a bit worse than a normal USB connector, but that is a price I am willing to pay for a lot less work on my side. This is already the end of this video. I hope you enjoyed it, and I would love to hear some feedback. And with that, bye!